Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on August 7th, 2025, just yesterday. So, it turns out that many of the best AI models for complex reasoning, the ones that are great at math and code, are actually pretty bad at sticking to the facts. This paper introduces a new training method that cuts their hallucination rate by an average of 23.1 percentage points. The paper is titled, Learning to Reason for Factuality, and the implications for training more reliable models are quite significant. The authors show how to boost not just factuality, but also answer detail, all while making sure the model remains helpful for general questions. And it's already getting some attention on X, with one of the authors, Jason Weston, posting about the work. He highlights the new reward function for training, specifically how it's designed to stop what they call reward hacking. This is done by making the model balance factual precision, detail, and overall quality all at the same time. The post is seeing some good engagement as well, with over 150 likes already. So let's dive into what makes this method so effective. Okay, so this figure shows exactly what that reward hacking problem looks like. On the top, you see the typical reward systems for tasks like math or coding, where checking for a single right answer is simple. But that approach fails for long-form factuality. So down below we see their new, multi-part reward function. It cleverly combines factual precision, the level of detail, and answer relevance, which is checked by another model acting as a judge. This three-part check is what stops the model from finding easy, but unhelpful, shortcuts. Alright, and this table lays out the results, showing just how well that new training recipe works. If you look at the bottom row, their final model, trained with online group relative policy optimization, hits an average factual precision of 68.1%. That represents a massive 23 percentage point jump over the base model. And crucially, it also increases answer detail, all while maintaining a high win rate, which confirms the model stays helpful and doesn't just chase facts at the expense of quality. This table then digs deeper into why that three-part reward function is so critical. It's an ablation study, which is where they test each component of their system separately. When they reward only for factual precision, the win rate actually drops to 43.5%. And if they add the detail reward on top of that, it gets even worse, plummeting to 36.9%. It's only when they combine factuality with relevance that the win rate jumps up, proving all three parts are needed to stop the model from taking unhelpful shortcuts. Building on that, this next chart shows what happens during the training itself. It tracks the length of the model's internal reasoning, its chain of thought, and the final answer. We see that both lengths shoot up dramatically in the early stages of training. The authors suggest this means the model first learns to produce more detailed responses. After that initial growth, the lengths plateau, likely when the model shifts its focus to fine-tuning the factual precision and relevance of those longer answers. So, to wrap up, this work really highlights that teaching models to be factual isn't straightforward. The key takeaway is that simply rewarding factual precision leads to lazy, unhelpful answers. The solution lies in a smarter training process using reinforcement learning, which is a method where models learn from rewards. By using a special reward that balances precision, detail, and relevance, the authors dramatically cut down on hallucinations, making these powerful reasoning models far more trustworthy. That's it for